Let's look at first how to convert this difference equation into a map. First, we need to understand what the difference equation is, what it means over here. If you look at it over here, we can rewrite this way. This means an plus 2, this one over here in the sequence, is equal to 3a and n plus 1 and minus 2 an and plus 5. So if you think about what it means, it's this. You have a sequence of numbers, and this one over here is an, and here you have an plus 1, and here you have an plus 2. Just says the number over here, this number can be obtained by a formula about these two. So you combine this and you get the next one. So this is what it means. Okay. So now, when we do the map, we need to see the following thing, that if we want to convert this one into a map, we're going to need two variables. The reason is we now can say that from these two, we can say this is x and this is y. And then you can move forward, and then we get two more. X moves to y and y moves to the next one. And that's why we say this difference equation is of degree 2, because you see the gap over here. The gap has length 2. Here is 1 and here is 2. Okay. So when you see this gap size is 2, that means we need to have two variables in the map. And this is what we're going to do. We're going to call this a sub n to be, say, xn. Okay? And this one over here is going to be yn. So we're going to just call yn is going to be a of n plus 1. Okay? So now we're going to move forward. You can see yn is really just xn plus 1, right? Because xn is an. Xn is an, right? So yn is really just xn plus 1. That's what we're saying. But if you look at an plus 2, and this one over here is going to be yn plus 1, because yn is over here, a of n plus 1. So when you see this, then you look at the equation over here, then you can have yn plus 1 is equal to 3, and then an plus 1 is going to be yn over here, right? And then minus 2 xn and plus 5. And if you look at this relation over here, we only have the gap size over here 1. It goes from n to n plus 1. That is the notation for the map. Now you may say, where is the other one? The other one is in fact the one we introduced. So you have xn plus 1 is equal to yn. Just switch the sides, and then what you have this one. Now because this is a linear affine system, you can express this one in the familiar matrix form. You can say xn plus 1, yn plus 1. And that's going to be equal to something over here we have. Sorry for the interruption. Now let's continue. So we switch the order of x and y. So we have in the natural order. Then if you look at it, the matrix coefficients we're going to have over here is 0, 1. That's because we have yn over here. And then you switch the order, then we have negative 2 and 3. And here we have xn and yn. Okay. And then we have from here 0, 5. This is a matrix form. If you look at it, this is one step from n to next one, n plus 1, right? And that's the matrix form. Now you may ask, what if we have a gap size more than 2? What can we do, especially if there is something missing? So let's look at another example. Say suppose we have a n plus 3 and minus 3a n plus 1 and plus 2a n is equal to 5. What can we do? The principle is the same. So if you look at it, what you have over here, you start from a n, and then you have a n plus 1. And this one is skipped, but you can see that's just saying there is a 0 coefficient in the front. And then here we have a n plus 3. So if you look at this difference equation, what we have is that the n plus 3th term over here we have is equal to 3a n plus 1 and minus 2a n and plus 5. So if you look at it, what it means is that in order to find a n plus 3, you're going to need 1, 2, 3 variables. So you're going to call this one over here xn, and this is yn. So let's say this is going to be cn. So what you see over here is that xn is going to be a n, right? And yn is going to be a n plus 1, and zn is going to be a n plus 2, right? And then from here you can see, because all these x, y, z's, that are really just this sequence an's, so you can see that this is really xn plus 1, and this is really yn plus 1. So, and then you will see that your system becomes xn plus 1, yn plus 1, and zn plus 1 is equal to, okay, this is going to be yn, I'm going to put in the middle, and then yn plus 1 is zn, I'm going to put at the last, and zn plus 1, that's an plus 2. Yeah, one more. Cn plus 1 is going to be an plus 3, right? So now you will have, this is going to be 3an plus 1. You're going to use yn, so you have 3yn, okay? And then this part is negative 2x, and that's okay, the order, and then this is plus 5, right? And if you look at it, now we are in the form, nearly in the form of a map, because on the right hand side everything is about n, and on the left hand side everything is about n plus 1. So in the matrix term we have xn plus 1, yn plus 1, and zn plus 1, right? And just carefully extract the coefficients, and then this is going to be 0, 1, 0. That's because you have 0xn plus 1yn and a plus 0zn, right? And then for the second one, you're going to have 0, 0, 1. Last one, you have negative 2, 3, and 0. And then you have xn, yn, and zn. Okay? And plus 0, 0, 5. And that would be the matrix form. Of course, this is linear difference equation, so we have this linear representation in matrix. If it's not linear, you cannot do this, of course. All right, and that's everything we need. You may say, how can we convert a map into difference equation? That's usually rare. We not do that all the time, but there is a way for linear maps especially. We're going to skip that topic for the moment.